Hello students, welcome to Vyas Certification Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 11th. The chapter that we're dealing with is sequence and series. And now is the turn of exercise 9.2. This particular exercise is based upon arithmetic progression and its related concepts. So along with the questions, we'll be seeing the concepts involved in this particular exercise, and obviously you'll be benefited with the concepts, with the solutions of each and every question over here. The first question says, find the sum of odd integers from 1 to 2001. Okay. Sum of odd integers from this to this. So from here to this particular point, these two are also odd integers. We are supposed to consider these as well, right? So we have, let's say, the general method which says, okay, you have 1, then the next odd integer will be 3, the next odd integer will be 5, then you will have 7, and correspondingly you will continue up till 2001, and you are actually interested in the sum of this particular series, this particular sequence, right? Sum of this particular sequence, or when you form the series, the sum of that corresponding series. Okay, odd integers we have written. The formula, the important thing about arithmetic progression, let's note those things. So an in general is a plus n minus 1 d. Two things are important, the first term and the common difference. If you know the first term and the common difference, you can always find the nth term. The sum of first n terms, mind you, sum of first n terms, you have to start from a, right? Sum of first n terms, which is actually a plus d plus a plus 2d plus dot 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 plus a plus n minus 1 d. This is the expanded form, and this can be clubbed together to give you this formula. 2a plus n minus 1 d. How do you obtain this result? By simple modification. Basically, you write Sn directly straight, and you write Sn again by reversing the order of the terms, right? And you add them to give you this. This can also be written as n by 2 a1 plus an. What is a1? a1 is a. And what is an? A plus n minus 1 d. Adding these two gives you this expression over here. So this can also be written as first term plus last term. N by 2 times first term plus last term. That's another version of writing this formula. But do you see that for finding Sn, you need first, last and n as well. Even if you have first and last term, you need n as well. Or in this formula, you need first term, common difference and n. So the important thing is you are supposed to find n. And for finding n, we are given an. In the for an, do you see that a, d, n and an are involved, right? If you know a and d and you know an, you can easily find n from here. That's the important thing, first of all. So from here, I can observe that a is equal to 1, common difference is equal to 2, an is equal to 2001. Once I observe these few things in this sequence, I see that an can be written as a plus n minus 1 d, or I can replace an by 2001, a by 1 and n minus 1 times common difference, which is 2. So 2001 minus 1 will be 2000, divided by this 2 will be 1000. 1000 is equal to n minus 1, and that tells me n is equal to 1001. N will be equal to 1001. If that is the case, have you found n? Yes, we have found n. That's the number of terms in this sequence over here. Therefore, the sum of n terms can easily be found. Sn will be equal to n by 2, and now I can use a1 plus an easily because I know an directly. This is 1001 by 2. a1 is 1 and an is 2001. This is what you have, right? So what does that become? This becomes 2002 divided by this is 1000. This is 1001. 2002 upon this is again 1001. So this into this is what you get, 1001 square. Yes. And what is that equal to? Can you find that square easily? Yes. Just multiply them. So what does that take me? 1001, and then you have 0 and 0 being involved over here. So what you have over here is, let's see, 1001 000 and plus 1001. is what you need, right? What I've done is I've written this 1001 as 1000 plus 1, multiply this with 1000 and multiply that with 1 over here. So that gives me 1002001. That is my required answer for this question, as you can see over here. This is the final answer for this question. Yes, this is the final answer that's required for this question, as you can see over here. One important thing to note over here is, you've seen these formulae, right? Sum of odd integers, when you talk about sum of odd integers starting from 1, or sum of odd natural numbers starting from 1, if you talk about 1, 3, 5, 7, up till ... Let's say nth odd natural number, the nth term of this sequence will be 2n minus 1. If you have first n odd natural numbers, comma, sum of these first n natural numbers is simply equal to n square. This is something which you can remember. And do you observe that sum of first 1001 odd natural numbers is simply 1001 square? Yes. Can you derive that formula directly as well? Yes, you can derive that formula for this expression. Since there are n terms, so n by 2 is the sum. First term plus last term, 1 plus 2n minus 1 is actually 2n. n times 2n divided by 2 will be n square only. And that is something which you can remember for future, right? This is the complete solution of this question, and some extra concepts which we have discussed over here are covered, right? With this, we come to the conclusion of this complete solution for this first question.